Okay, guys, today we are talking 6 points to the beginning. Just the beginning. Alright, it's just a little bit of review. I think it's from chapter 2 where we do some transformations. So we're all about transformations here today. Tomorrow, you better bring your big boy pants because it gets complex, alright? And maybe your Z-score sheet too, because, well, I trust you guys. You'll be able to bring it. You'll be able to bring it. Alright, so let's go. Chapter 6.2, and we're talking about transforming things. Moving along, and just as a little review, what happens to a number when you multiply it? What happens to the mean and standard deviation? So, for instance, let's just take the numbers, shoot, if you can't remember, let's go 2 and 5. I'm just going to pick two numbers. Now let's just say that is my distribution, right? Okay. What happens if I multiply everything by, let's go 6. By the way, would you guys agree that the distance here is 3? And where's the mean? The mean would be, oh my goodness, 3.5, I guess. Alright, so the mean is 3.5 right now. The distance between the two is 3. What happens if I multiply everything in my data set by 6? Well, my new data set is going to be 12 and 30. Alright, so my new mean, 12 and 30, 42, 21. Whew. 21 is my new mean. And the distance is 18. Alright, now what happened when I multiplied? When you multiply, okay, what changes? Well, the center will be multiplied, right? Multiples are dividing, okay, and your range, your IQR, your standard deviation also is multiplied, right? Because my range, it went from 3 to 18. That's a multiple of 6. And my mean went up by 6. If you take 3.5 times it by 6, you get 21. So when you multiply all your numbers in your data set, your mean will go up, and your standard deviation will go up by whatever you're being multiplied by. Pretty sweet, eh? Alright, so let's introduce you to the story problem. We're going to be focusing on the story problem the next couple days. We got Pete. He owns a Jeep tour. Alright, and he loves taking people on tours. In fact, I think sometimes we should have like maybe a little Craig Jeep tour where we can like kind of scoop people around. You know, just show them, here's, you know, the good drinking fountain. Here's where some kids fought last week. You can still see the blood on the locker. Just kidding. Okay, well, we probably could get some good money. Pete's Jeep Tours offer a popular half-day trip to tourists. Okay, there must be at least 2 passengers for the trip to run. Hence, that would be why my lowest possibility is 2. And I can only fit 6 in a vehicle, so my highest is 6. So I could have anywhere from 2 to 6 people in a vehicle. And here are the probabilities. Pete is a statistician. My man, Pete. He has actually recorded the days that he gets 15%. He gets 15% of only 2 per day. 3 gets 25% per day possibility. 4 people show up. Has a 35% chance, and so on and so forth. So, how do we describe this? Okay, well, first of all, I want to make sure I know where the mean is and the standard deviation of Pete's. Okay? We're going to call this, and they said define it as x, so I'm going to call this the mean of x and the standard deviation of x. Sweetness. Alright, now, I could go whoop, right? Remember that? Whoop, whoop. We could do this. I could do that. Multiply down, add across, that kind of thing. That only finds me the mean. So I want the mean and standard deviation because whenever I'm describing stuff, I like to say the shape, which appears normal, right? Would you say it's roughly normal? the center, which is the mean, and the spread, which is the standard deviation, since it is normal, right? Okay, remember, if it's skewed, you should use the median and IQR. How much time do I got? We're only 5 minutes in. We got all day! We got all day! All right. Okay. Oh, one more second. Just so you don't think I'm like drinking wine or something while I'm teaching. I'm actually drinking Cran Raspberry. Taste the ocean. I don't know what the slogan is for raspberry, but not wine. Okay. I'm going to take my calculator out and let's blow you up. There we go. Okay. And I'm going to go to stat, the heart of the calculator again. I'm going to go right into that edit category. And by the beauty of math, I have already typed in my L1 and my L2. You guys cool? All right. Type in your L1, L2, hit stat again. I'm going to go over to calculate. And remember, I know I put it into 2, but this is a 1 variable. It's how many people show up, right, on a given day. It's 1 variable. I put my list in L1, my frequency or my probabilities that it happens in L2, and I'm going to calculate that sucker, and there we go. So, let's change it back, and I got a mean of 3.75. Just a second. You going to bed? Ooh, Ocean Spray's music. You know what? Let's see. Alexa, what's Ocean Spray's slogan?
Sorry, I don't know that. I Googled it.
She Googled it. Alright. You going to bed? Alright, she's just Googling Ocean Sprays. I think it kind of sounds like the Skittles. Taste the rainbow. Anyways, 1.08. Oh, let's give it 9. Oh, we're going to give it one more 7. You don't really need to go that far, but... Alright, so the mean is 3.75. Standard deviation is that. Lotta. Look at that. I could have just done that, I guess. Right? Just slide it down. Alright, now, Pete charges $150 per passenger, though. Ooh. So he expects 3.75 people per day, roughly. That's an expectation. So if he charges $150 per person, what would be my mean? Oh, let's not show that one. Let's not get ahead of ourselves. Okay. 150. Well, he charges $150 per person. Well, basically what that means is each one of these guys gets $150 to Pete. Man.
For doing what?
Giving them tours. Like, I don't know, around Craig.
What kind of tour is that?
$150. It's a half-day tour, too. It's a half-day tour. Yeah. All right. 3.75 times 150. All right. So if I times those, the mean of the amount he collects. Now notice we're changing the mean now. It's C. We're going to call it C. The mean of C, which stands for collection. That means it is going. I multiply it basically. 150 times 3.75, and it goes up. What am I doing? I'm going to turn that into 5. 62. I got to get cracking. I'm really. All right. So $562.50. That's how much you should expect per day. Pete is raking it in. Now we could figure out how much he could expect in a week too. How would we do that?
You're in the wrong profession.
Times by 7, right? Okay. Standard deviation for the collection. Well, that's standard deviation. Okay, thanks. Thanks. My wife is pouring water.
Trying to get some water out
Can
of
you? We're out of water. That's why I'm drinking Ocean Spray. Not water. Okay. Anyways, let's see. So I'm going to take 1 point. And that baby is also going to get 150. So I'm going to go 150 times 1.0. I'm just going to go 1.09, and I get $1. Actually, $163. So it could vary by $163 also a day. Whoo! You know what? Pete might be able to double this. If it's a half-day tour, he might be able to double that. He might be able to do 2 tours in a day. It's like 1,011. Actually, whatever. Okay. Cool. Sweet. Any questions so far? Like I said, today's going to be a pretty chill day. You should be able to handle today. Tomorrow, especially if you're watching these videos. If you're watching these videos, you're screwed. You don't even have a shot. Okay. How does adding and subtracting... Okay, oh yeah, so how does adding and subtracting affect it? Now, I only got 4 minutes, so let's do the same stinking... Now, let's change it up. Let's go 1 and 3. All right, I'm going to pick normal numbers. Okay, would you say that they vary by 2, right? That's their range. And the mean would be right in the center at 2. All right, wow, that's kind of weird. Okay, now what if we add or subtract? Let's say we add on now. Everything gets 6. So instead of 1, that's going to be a 7. Instead of a 3, that's going to be a 9. All right, now how has things changed? Well, my mean has gone up to 8. Well, guess what? My mean has gone up by 6. Woo! I get to add 6 to my mean. However, here's the dirty booger. Your range still stayed at 2. Okay. Still stayed at 2. So therefore, when we add or subtract, the mean will go up or down, depending if we're subtracting. But the standard deviation and the range, the IQR, all that stuff, does not change. Okay, so let's see an example of poor Pete here. All right, so consider Pete's Jeep tours again. We defined C as the amount of money. All right, and this is the amount of money here. All right, so we figured that out last problem, right? Cool. Now, it costs Pete $100 per trip to buy permits, gas, and ferry pass. Wow. Okay. For a vehicle, I guess. So, the random variable V describes the profit. What is his profit going to be? I'm not going to show that. You don't even need it. All right. So what is going to be the mean of his profit? Like cost, yes, so he's raking in that much money, but what about profit? So profit we're going to call V. I don't know why we don't call it just P, but P for profit, you'd think. But we're going to call it V to describe how much money he'll actually make. Well, remember, we will subtract $100, right? So that 100 goes to this guy, right? We're going to subtract it. So now the new mean of profit, he's actually walking away with only $462. See, honey, he's not really making that much money. Teaching still gets way more money than doing a tour around. Yeah, he's still making, he's only making $462 a day. Psst, chunk change. Okay, and the standard deviation. Sorry, holy moly. Alright. Okay, standard deviation for V. Oh! No! Don't go over there. Alright, cross that out, right? Because when we subtract, nothing changes. The deviation, remember, the deviation does not change. It just basically, it takes it, sorry, let's go this way. It takes it from here, and it moves that sucker up just a little bit, right? The deviation doesn't get wider, okay? So when we add or subtract, the deviation does not change. So we're going to still stay with $163.50. Alright, I don't know what this is. Yep, probability of V. Here we go. Look at that. Alright. Let's see. We're going to save that. This talk's going to be for tomorrow. Alright, now notice on the back of your page. Oh, there we go. Alright, you should be able to do question number 1 by yourself. And work through some other problems on this. Have a great day, ladies and gentlemen. See you tomorrow.